Hi, I'm Bryan with Pioneer Builders. Today I'm at InnoTech Windows and Doors. I'm in Langley, Canada. These guys make amazing products. I'll take you inside and show you some of the features. All right, I am inside the facility with Mike here. He's going to give us some of the ins and outs. Mike, maybe tell us a little bit about yourself.
Well, I'm the business development manager here at InnoTech. I've been in doors and windows for most of my career in construction, so that's getting on about 30 years now. And I find all this stuff pretty fascinating, and I enjoy building science and how windows tie into all of that.
Cool. Mike's only 35 years old, so he started this when he was 5 years old.
Exactly.
First thing we're going to do, come on over and we'll show you this new testing chamber. They have an older one that was pretty well top of the line at the time. Now they've gone completely next level with this one, and Mike can give us some of the rundown. So what are we looking at, Mike?
Well, so this is our newest, fanciest thing. We're actually just finishing it up right at the moment, making sure that everything is properly testing out and giving us exactly the results that we require, so that we can run our tests and know that what we're testing actually matches the testing that's done in our third-party certification labs.
Okay.
So the way this thing works, it's kind of a cool modular, semi-modular system here. So these are the nozzles that spray out. They have a fixed rate.
And they would be spraying out water.
They spray out water.
Okay.
We are able to pressurize the thing. We use either a vacuum or insert pressure so we can go negative or positive on the pressure. Test our air tightness. And that air pressure allows us to simulate structural pressures, the wind loading that would normally occur for a window or door. So we can add little rods in here that support the product. It allows us to put clamps on it. So we hold the product tight up against the wall, blast it with water, crank up the pressure, and really simulate the realistic weather conditions.
Cool. Now, is it only the exterior weather that you would be testing for? Is it just outside stuff, or are you testing for air tightness on both sides of the window? How does that work?
Great question. So obviously the water is only going to be from the exterior.
Well, we hope so, but
Yeah.
I've got 3 kids, so you never know.
Yeah, that's what we test for. Yeah, whatever you're doing in your house that causes you to need watertight windows.
So it's really
that's your
weather.
issue.
Weather is what you're testing for the water side.
And then for air, it's just going to be, so the pressure is either pushing or pulling so that we can tell how airtight it actually is, how well it's sealing up. So we want to know if air is leaking out. That's your heat loss, or one of your methods of heat loss. And then when you're pushing against it, that's both the stress and how much air is going to find its way in. So maybe cold air actually pushing its way in the wintertime.
And now it's not just a matter, though, while people in building science are all worried about heating and cooling and everything, is there a structural component to it because we're dealing with wind loading? Is there anything as far as seismic with how these are constructed to resist those more structural forces?
Yeah, well, in terms of structure, yes. So when the air pressure replicates the force of wind that's going to come up against it.
Okay.
So there's only a certain amount that we're going to crank it up to in this test chamber.
Got it.
But we can tell we're pushing on it with air pressure. That's the same as wind pushing against it, causing deflection, twisting, whatever's going to happen there. This does not do seismic testing of any good. Seismic testing would be trying to actually
rack
get
it and all that.
Yeah. So there are some people in town that do that kind of testing. Cool. That's a whole other ball
thing.
wax. Yeah.
Well, cool. Looking forward to you guys getting this up and running, but maybe you can just show us some other things on the show or on the production floor here. Yeah. Anything else before we keep walking you want to say about this?
Well, one thing that is kind of cool is that it does recycle the water.
Okay.
So little tiny bits might dribble out here and there, but for the most part, it's captured water that's constantly just being filtered if necessary, but it's just recycled, nice and clean, very limited waste.
And I guess maybe for the technical nerds out there, does this mimic an ASTM standard test method of any sort, or?
Yeah, it's the test methodology as defined by the NAFS program, the CSA A440. I do not know the exact parameters of it, but we can mimic the ASTM site testing that you would normally see.
Okay.
So I think it's E1107. But so we can do continuous testing, we can do the cycle testing, we can do basically whatever's
Cool.
required to ensure the robust performance.
Awesome. All right, let's go to another spot.
All right.
One thing about these windows is they're extremely strong. So if you've ever seen a concrete cylinder, they'll actually break those with a hydraulic press. They do something similar with their windows. So imagine this is the corner, and they'll cut it, put it in here, and the press will come down, and you can see how it's kind of cracked this. It's crushed it. The way they take their UPVC, it ends up essentially acting as if it was extruded in manufacturing. They just end up doing that here on site. As they crack it, what you don't want is the seam to be the weak link. So you can see it's actually the UPVC that failed, which someday it will fail. It's just gonna take a certain amount of force to do that. And then here, you can see that it's over here. That's where it's really receiving just a ton of pressure to try to separate that as the press comes down. Now, one interesting thing, that's 10.5 newtons of pressure. Another window might be more like 2,000, 2,500. So that gives you an idea of the strength. All right, let's keep moving. Over in this area, you can see that we've got the structural components. You know, windows might have plastic, they might be wood, whatever the case is. Sometimes you have to have different products in order to really make it stronger. So that's what this is here. And we won't spend too much time in this station, but it's not just the outside that you see on windows that's important. It's the construction of what goes inside. And I'm not gonna hold this too much longer, but I don't know that I'll have to go to the gym today because it's definitely strong steel. All right, I wanna show you the Aerogel product in a minute. I've never seen it before today. Now we're in an area that's got Aerogel. This is something I've literally only ever read about. So there's lots of different insulation materials out there. You're used to fiberglass, spray foam, whatever the case is. Mike, tell us about Aerogel. What is this stuff?
Yeah, it's pretty funky. It's some people have called it. You may have seen it in different things. It's this stuff happens to come in a blanket form. There's different ways you can see it. It's almost like an insulation that somehow it's like lighter than air. It's just really crazy stuff. I think they developed it at MIT. It's pretty neat. But this is, you know, the pure natural state isn't the thing that's usable for anybody. So they make it like this in a blanket. It kind of looks a lot like traditional, like fiberglass or
almost looks like
insulation.
a rock wool,
yeah, it's fibrous, but it also has this powder in it that, like, I can rub it on myself and see how white it makes my fingers. It's just an inert substance. It's not toxic or anything like that, but it is this weird fibrous and dusty material that gives just absolutely incredible U values or insulation values. So this stuff, it works out to about an R10 per inch.
Okay.
So, you know, adding an R5 with a little half-inch strip into the window frame can make this absolutely crazy difference in our total performance.
So I was just looking over the structural steel stuff. Does this play with that at all, like wrap it to help with the conduction, or does this not play into the structural steel part?
Yeah, it's one of the ways that we help to prevent the thermal conductivity. The Aerogel itself isn't going to be paired up with steel most of the time. If we have to put steel structure in, it's such a huge thermal bridge. There's always something that we have to do to try to offset that. Sometimes the profile engineering has air chambers and things like that. But our very highest performing windows, we need the very highest performing insulation to really get to that top level performance. Yeah.
Very cool.
Aerogel is one of the methods.
Awesome. All right, let's keep moving.
All right.
Okay, Mike, so now we're over at the corner cleaner, and tell us what we're looking at.
So this is one of those critical things to ensure your air and water tightness. You need to have the air seal and the surface that it's mating against come together as close to perfectly as possible. So this thing cleans off all those little squeeze out bits that happened during the welding process and make sure that it's nice and smooth and everything's going to avoid all those potential pinholes.
Perfect. You know, speaking of welding, why don't we show the folks over there what that actually means? Okay, Mike, so what is the name of this machine, and can you explain to us what our technician is doing?
Sure, I'm sure there's a very complicated name in German, but it's a forehead welder. So this will weld all four corners at the same time. That's to ensure that it's going to be welded as a square component and that it's the correct dimensions. So right now it's clamping everything and aligning it. Now the spacer block has moved out. Heating pads come in. They're at 250 degrees Celsius, or I don't know, around 480 Fahrenheit. So fairly warm. And they're going to maintain contact for the specific amount of time to cause it basically to go back to almost fluid at the ends. Then it's going to press together and hold it there for the correct length of time. It's all very, very specific to ensure that we get the weld strength that we want. There's a little arm that comes down and presses on the gasket because the gasket is also part of the welding process. So all three gaskets that are on the profile are heat welded at the same time as the frame profile is welded. There's a bunch of squeeze out in the corners during the welding process. And that means that the most amount of UPVC that's in the profiles or in the frame is all going to be at that weld point. So the seam should actually be the strongest part of the window.
Very cool. So one thing, the seals then aren't rubber, is that right? The seals aren't actually rubber?
That's right. It's a high flexibility PVC composite. So that's co-extruded. It's part of the original extrusion process. They are replaceable, but they are going to perform that slight bit better if it is the original extruded. So best not to physically damage it when it gets to site.
So Mike, kind of the bottom line of all that, it ends up making the frame act monolithically. It's like very strong as an entire unit, even though they were parts and pieces. And then ultimately that makes the frame stronger, but then it also helps it to be more airtight, which circles all the way back to the very first thing we saw with the test chamber. This is how you end up feeling comfortable over there that your windows are going to perform well.
Exactly. The temperatures that we bring it to, the amount of material, the amount of pressure, the amount of material that's squeezed out, the length of time that it's held for under heat, the length of time that it stays there resting to cool down afterwards. This is all very specifically engineered to give us the maximum strength possible.
Cool, very cool. Well, maybe we can look at least one more thing and see if we can watch somebody glaze the unit. I think that was pretty cool.
Sure.
She's putting on some hardware back there, and first of all, yeah, we're taking a little detour. Way interesting to see how proficient she is in what she's actually doing. And those little weight things make her job so much easier, but I guarantee you, she's making it look way easier than anything I could do. I did want to show you this. You've made it this far in the video, don't give up on me now. This particular screw is machine threaded from here to here. So earlier we talked about that steel. If they have to go into the steel, the machine will go in there. The threading from here marries well with the UPVC. So if this screw is being used, it's binding into everything that it has the capability of. And then all the way down to the head of the screw, this shape goes into whatever the piece of hardware is. It's just those little things that impress me, the forethought and engineering that went into all of this so that it very logically works together. Okay, now we can take off. Okay, Mike, so help us out here. This is where the rubber meets the road. And maybe you can just explain to us what he's doing while he's doing it.
Well, so with this system being dry glazed, so he starts off and obviously he's got those little base plates and then shims on top of it. Those plates give us a flat surface to shim on. So he fits the glass in. Obviously he's fairly experienced with doing this stuff, so he knows what he should be doing to set the glass in correctly. They want to have a nice even edge bite. Ooh, that's a nice heavy unit. He's moving nice and easily. I do not recommend one person moving that unless you have a fancy crane apparatus like that. So now he's just doing the final set on there, shimming it out so that it's, of course, appropriately spaced within the sash. And then, because it's dry glazed, that means that that's really all he has to do until he puts the structural glazing bead on. So that's going to have a pressure fit gasket on there, and those glazing beads go in, they get malleted into place, as you'll see in a moment.
So what's the difference between dry glazing and would it be called wet glazing? What's the terminology?
Yeah, that's actually a great question. Wet glazing or dry glazing, and sometimes dry glazing means different things. So we don't use any adhesives between the glass and the frame, other than just the pressure from that gasket system. Some companies will use, it's still called dry, but they use adhesive tapes and things like that. Wet glazing is where you just use caulking to glue it in place. And the difference on this is the glass has the capacity to move in comparison to the frame. So our system is able to accommodate a lot more frame movement, a lot more building movement without causing problems for the IGU. And what it generally means is lower chances of glass breakage and significantly longer IGU lifespans. It's also a heck of a lot easier to do glass re-and-re on there. So if you do happen to get breakage or something like that down the road, you just pop the beads out, pull the glass out, new glass in, beads replaced. So it's a pretty quick job.
So how many of these units can this guy do in a day, do you think? Do you have any idea?
That's a really good question. I would expect to see him do at least 100 units.
Well, he is impressive to watch, that's for sure.
Yeah, it's a couple of minutes there. I mean, he's pretty good at what he does. He's a glazier.
And now what's he affixing to there?
So that's the label that tells us a whole bunch of details about that exact window. So that will tell us the U value of that frame combined with that glass at a specific size, that's NFRC. It tells us the NAFs, the AMA test parameters for it, like the certified values. So it gives a performance grade. That's for structure, air, and water performance. And it also gives some Energy Star information. So there's quite a bit on there that you can use as a builder or a specifier to verify that the product meets your needs.
Sure, maybe even a rater, building inspector might want to look at that information.
Absolutely. In around here, it's actually, that label has to stay on until final inspection.
Yep. And that brings us an end to the tour, but we're not quite done. We're gonna have Mike go ahead and show us this particular finished product. Mike, tell us what we're looking at.
So this here is a large coupled unit, pretty good size as you can see. So we've got our black thermofoil finish on there that will stand up very well to the riggers. This is going a fair ways up north, so it's intended to be exposed to a very rough climate, and it's going to stand up to it just fine. Fixed to fixed, and then we have the tilt turn that we're just shipping that separately for ease of shipping. Yeah.
Very nice. I love it. Well, thanks so much for having us up here for this trip. Mike, is there anything that we should know that we didn't talk about today?
There's always a ton, and I love to answer questions. So if people want to drop me a line, they should feel free to do so.
How can they do that?
We have obviously our website,
okay.
InnoTech-windows.com.
InnoTech, that's how you spell it, okay.
Yeah, INNOTECH.
Got it.
So the website's fantastic, and there's tons of content on there.
Yeah.
There's a lot of project profiles that you can go through. We have social media channels, but yeah.
Cool, so lots of ways to get a hold of you. I will tell you, I appreciate they've got details. If you're a window specifier or even an installer, you want to make sure what you're specifying and then make sure that translates into the field so that you can think about things like what your finished floor heights are going to be if you've got terrace doors that are going to be opening. Our next stop in a future video hopefully Mike will be back with us because we're going to be installing some of these. We've got a whole house that's going to have a couple of terrace doors, lots of different windows, and it was definitely worth our time coming up here and see how it's made. Well, thank you so much for watching. Again, I'm Bryan with Pioneer Builders. I've been on the Build Show for about 1.5 years now. If you want to see more of the day-to-day operations, I'm at Pioneer Builders Inc. And of course, on Build Show, there's a bunch of different people. Matt was actually here a while ago, and if you want to see an even more in-depth video for how these units get made, check out Matt's. We might even be able to link to it below. Well, thanks so much for watching. We'll see you next time on the Build Show. Now go build something.